Today we will be talking about limits by factoring. In fact, this video is a continuation of my previous video. My name is Janine Ko and I make educational content related videos like this. If you're interested in seeing more, please subscribe to the channel and hit that notification bell. For this example, we have limit when x approaches 2 and you have x squared minus 6x plus 8 all over x minus 2. So right off the bat, you see that when you plug in 2 into your expression, x squared minus 6x plus 8 all over x minus 2, you actually get an indeterminate form. So we have 2 squared minus 6 times 2 plus 8 all over 2 minus 2. This results to 0 over 0, and this is actually problematic as we've discussed from our previous video. Now, in order for us to get rid of this indeterminate form, we can actually factor our numerator, which is x squared minus 6x plus 8. And just as a recap, how do you factor quadratic expressions? So you would have to think of two factors. When you multiply them together, you actually get positive 8. And when you add them together, you get negative 6, which is the coefficient of x. So we can have x minus 2 times x minus 4 for our numerator, and this is the factored form, just because when you have negative 2 and negative 4, when you multiply them together, you get positive 8. And when you add them together, you do get negative 6. Now, this is all over x minus 2. So as you can see, this x minus 2, both in our numerator and our denominator, is causing you to result to an indeterminate form. And now we can cancel out x minus 2. And finally, we are able to evaluate the limit when x approaches 2. And we just have x minus 4. Now we can apply direct substitution by plugging in 2 into our x value. So we would have 2 minus 4. And hence our limit for this question is negative 2. Moving on to number 5, so we have limit when x approaches negative 5, then we have x squared plus 5x all over x squared plus x minus 20. So as you can see, when we substitute negative 5 into our x, you actually get an indeterminate form once again. So we would have negative 5 squared plus 5 times negative 5. This is all over negative 5 squared. And because this is a plus and you have negative 5, this becomes negative 5. And this is minus 20. We get 0 over 0. So as you can see, it's an indeterminate form. Therefore, we want to get rid of this indeterminate form by factoring. If we look at our numerator, we see that we can have a greatest common factor, which is x. So we factor out x and we're left with x plus 5. Now for our denominator, we see that it's a quadratic expression. So again, you need to think of two factors. You multiply them together, you get negative 20. And when you add them together, you get just positive 1 because the coefficient of x is 1. So we would have x plus 5 and this is x minus 4. And it fits because you have positive 5 and negative 4. You multiply them together, you get negative 20. And when you add them together, 5 plus negative 4 or 5 minus 4 is actually equal to 1. Great, so we can cancel out x plus 5 in our numerator and our denominator, and now we can start evaluating our limit when x approaches negative 5. So we have limit when x approaches negative 5, we have x over x minus 4. We plug in negative 5 through direct substitution, so this is negative 5 over negative 5 minus 4. We get negative 5 over negative 9, and this results to 5 over 9. And hence our limit for this question is 5 over 9. And as you notice, the first thing that you need to keep in mind whenever you're trying to evaluate your limit is to apply direct substitution and see if it actually works. And from there, if you get an indeterminate form, that's the time you figure out a technique to get rid of that indeterminate form. So if you look at number 6, we have limit when x approaches negative 1, we have 2x squared plus x minus 1 all over x squared minus 4x minus 5. So as I just mentioned, we plug in negative 1 using direct substitution. So we have 2 times negative 1 squared plus negative 1 minus 1. And this is all over negative 1 squared minus 4 times negative 1 minus 5. So even though we do have a fraction and you're very tempted to plug this entire fraction into your calculator, don't do that just because you want to make sure that you evaluate your numerator individually from your denominator, because otherwise if you do get, let's say, 0 over 0, you're going to get an error in your calculator, and that's the last thing that you want to happen. So all you do is you plug in -1, solve for your numerator first. So you have 2 times -1 squared, and this is plus -1 minus 1. This gives us 0 for our numerator. And then solve for your denominator. So you have -1 squared, and this is minus 4 times -1, and this is minus 5. And this gives us 0. So as you can see, it's an indeterminate form. So now, because we have an indeterminate form, and you probably guessed we need to apply factoring in order to get rid of that indeterminate form, and because this video is all about factoring anyway, in that case, I am going to show you a very neat trick that I wish I learned back then. So all you have to do, if you're using a Casio calculator, just click on mode. It's right beside on. So click on mode, click on number 5 for equation, click on number 3 for a quadratic equation, and there you have it. So you have ABC. The only reason why I'm asking you to use your calculator right now is because, first of all, you can, and second, you're not really being tested on how to factor. So that skill is not being tested whenever you're trying to solve for a limit. It's all about finding what the limit is. So that's the skill being tested. And also, if you think about it, if you're going to apply the quadratic formula and on top of that find the limit of this expression, it's very time consuming. So just consider, the quick way. So you take 2 and plug that into your calculator for A. For B, you have 1. For C, you have -1. Then all you have to do is just click the equal sign every time you move from A to B to C and to the final answer, and you get 1/2. So our zeros are x is equal to 1/2 and also -1. So as you can see, because it's 1/2 and -1, that means our factored form would be 2x, and this is -1 because x is equal to 1/2, and you have x plus 1 because x is equal to -1. Then this is all over x squared minus 4x minus 5. So it's either you apply the technique that I just taught you, which is to plug it into your calculator. Alternatively, you can think of 2 factors, you multiply them together, you get -5, and when you add them together, you get -4. So let's just proceed with the calculator method. So you have 1, then you have -4, then this is -5. Okay, so we get x is equal to 5, then we have -1. So as you can see, our zeros are 5 and -1, so we would have x plus 1 and x minus 5. Just by looking at our expression, we have x plus 1 in both our numerator and our denominator, so we can cancel them out. Then we take the limit when x approaches -1, and this is 2x minus 1 all over x minus 5. And then we apply direct substitution, so we would have 2 times -1 minus 1. This is all over -1 minus 5. And during this step, you can actually take your entire fraction and plug this into your calculator. That's completely fine. So we have 2 times -1 minus 1. This is all over -1 minus 5. So we see that this is 1/2, and hence our limit for number 6 is actually 1/2. Moving on to number 7, we have limit when h approaches 0, and you have h plus 2 cubed minus 8 all over h. So if you haven't seen my previous video, which is all about binomial expansion, this is just a review. So I'm not going to go over the entire Pascal's triangle and how we derived the formula. So in this case, we would have a plus b, then this is cube, this is a cube, this is plus 3a squared b, and this is plus 3ab squared, and this is plus b cubed. So as you can see, we can expand h plus 2 cubed into h cubed, then this is plus 6h squared, and this is plus 12h, and this is plus 8. And because you do have that -8 in your numerator, we can just carry that over and have -8. And this is all over h. So this becomes 0. And as you can see, just by looking at h cubed plus 6h squared plus 12h, we do have a greatest common factor, which is h. So we can take out h, and we would be left with h squared plus 6h, and this is plus 12. and this is all over h. Therefore, we can cancel out h and be left with h squared plus 6h plus 12, and then we take the limit. So we take the limit when h approaches 0, and this is h squared plus 6h plus 12, and we just apply direct substitution. So we would have 0 squared plus 6 times 0 plus 12, then we would just get 12. So this is just 0. Moving on to number 8, so we have limit when t approaches 2, and you have t minus 2 all over t cubed minus 8. So the difference between number 7 and number 8 is just by looking at our denominator. This is t cubed minus 8. This is actually difference of cubes. So we would have to apply a cubed minus b cubed, and this is equal to a minus b, and this is multiplied to a squared plus ab, and this is plus b squared. So in this case, if we're looking at direct substitution first, because ultimately that's the first step that you have to do and apply anyways. So you plug in 2 into your numerator individually from your denominator. So you would have 2 minus 2, and this is all over 2 cubed minus 8. We see that this is 0 over 0. And again, this is an indeterminate form. Therefore, we're going to apply difference of cubes in order to get rid of this indeterminate form. So we're just keeping our numerator, which is t minus 2. And then just by looking at our denominator, we would just have t minus 2. And this is multiplied to t squared. And this is plus, because we're looking for our a value and our b value. Therefore, our a value is simply going to be t. And our b value is simply going to be 2. So this is plus 2t. And this is plus 4, because b is 2. And when you square that, you get 4. Now we can cancel out t minus 2 in our numerator and our denominator, because this is what's causing you to get an indeterminate form. And then you evaluate the limit when t approaches 2. So we would have 1 over t squared. This is plus 2t, and this is plus 4. And finally, we apply direct substitution. So we plug in 2 into our t. So this is 1 over 2 squared plus 2 times 2, and this is plus 4. So we get 1 over 12. Therefore, our limit for number 8 when t approaches 2 is equal to 1 over 12.